Hey everyone, how are you doing? Physics test should be easy.
Oh, hi Navesh. Yes, I hope so. Anyway, what are you reading, Solomon?
Oh, hey Navesh and yo. I was just catching up on Elon Musk's company SpaceX, sending their rocket into the space.
Oh,
His intention might not be acceptable for some people, but come on, isn't it impressive? Anyway, I'm pretty sure this has something to do with our upcoming physics test, which is about all three Newton's law and air pressure. It is really difficult for me as I don't fully understand. Perhaps any of you have any ideas about this?
Of course. But yo, do you want to go first?
sure Navesh. First of all, it's easier for us to understand that rockets like all objects are heavily influenced by Newton's law of motion as well. All the Newton's law of motion are used in the principle of rocket. In the first law, every object initially is at rest and it only starts moving when there is an external force acting on it. During the flight of the rocket, the forces are changing between balanced and unbalanced force all the time. Firstly, the rocket on the launch pad is in balanced force. When the propellant starts burning, they will produce a large force to push up the rocket. This is the external force acting on the rocket and it breaks the balance force of the rocket. Then the rocket will travel upward and further away from the Earth's surface towards the space.
If I remember correctly, we have studied three laws of motion. What about the second one?
Yes, you are right. In the second law, we will know that the force is the product of the mass and the acceleration. F equals to ma. The acceleration is inversely proportional to the mass. The lower the mass, the higher the acceleration. We are know that the largest part of the mass of the rocket is propellant. It nearly 90% mass of the rocket. 6% are the structures such as tanks, engines, and fins, and the last 4% can be the payload like the satellites. During the flight, the mass of the propellant is decreasing due to the combustion. This is because it burned to provide an upward force to the rocket. So we can see that initially the speed of the rocket is low and it starts increasing as the time goes. So Solomon, do you know about the Newton's third law?
Yes, I do. Indeed, I understand this part very clearly. In the third law, in the Newton's third law, every action will have its equal and opposite reaction. Therefore, due to this Newton's law, Newton rocket can take off easily. So, this law can be easily related to the principle of conservation of momentum. As we know, in the rocket, there are mixtures of liquid hydrogen and liquid oxygen. It carries this mixture, this fuel, which is also known as kerosene. So air from the atmosphere is drawn into the engine and compressed by the compressor. In the combustion chamber then, the fuel will burn vigorously with the compressed air. The hot gases formed will expand rapidly and are forced out of the nozzle at the high speed through the turbine blade that is rotating through the compressor. Therefore, at the exhaust gas, it will eject very high speed exhaust gases that will create a backward momentum at the exhaust gas. So, we understand that in accordance with the principle of conservation of momentum, a forward momentum for the engine is produced. Then the plane can finally fly forward. Sir. Well, seems like I still do understand physics after all. This is really fun. When a rocket launches, no doubt that we must not overlook on air pressure and resistance as well.
That's right. You know that burning the propellant produces high velocity gases. The upward force has more to do with pressure. We all know that pressure is force per area. If you put it the other way, force is equals to pressure, product of the pressure and area. Rockets have a special type of nozzle to expel the gas produced from the combustion of the propellant. This nozzle is called a converging diverging nozzle. How this works is simply gather the gas produced and increase the pressure at its neck where the area is small. Then this high pressure gas is expelled through the diverged end of the nozzle where the area is quite large. Therefore, this high pressure gas produces a great amount of force when it exerts the nozzle, causing the rocket to lift up.
Let's not forget that there are some stages for rocket to launch and fly to the sky too. Every stage does matter so that we can have a smooth launch. So that we can have a smooth launch of the rocket. And I have one question for Navesh. Do you know the rocket need a propellant booster to fly to the space?
Yeah, thanks for reminding you. There are actually two different types of them. One is serial and another one is parallel. In the serial staging, there is a small second stage rocket that is placed on top of a large first stage rocket. The first stage is ignited at launch and burns through the power axle until its propellants are exhausted. The first stage engine is then extinguished. The second stage separates from the first stage, and the second stage engine is ignited. The payload is carried atop the second stage into orbit. Serial staging was used on Saturn V moon rockets. The Saturn V was a three-stage rocket, which performed two staging maneuvers on its way to Earth orbit. The discarded stages of the Saturn V were never retrieved. And moving forward, in the parallel staging, several small first stages are strapped onto a central sustainer rockets. At launch, all of the engines are ignited when the propellants in the strap-ons are extinguished. The strap-on rockets are discarded. The sustainer engine continues burning and the payload is carried atop the sustainer rocket into orbit. And this parallel staging is used on space shuttles. The discarded solid rocket boosters are retrieved from the ocean, refilled with propellant and used again for another rocket launch.
And by the way, let's not forget about the rocket's design. Each part design serves a purpose. Starting in the tip, it's cone-shaped to modulate oncoming airflow behavior and minimize aerodynamic drag. And for the fins, they provide stability during flight to keep the rocket on the intended course through inducing rotation.
Oh, you asked me about the stage. For the stages that rocket launch and fly to the space, the propellant booster burns to produce a huge thrust force, so the rocket will lift up. That's for the first stage. And the second stage, when the propellant booster finished burning, they will attach from the rocket. Then the main engine of the rocket start working to let the rocket move towards the orbit. The rocket body will detach after consuming its fuel. And this is the third stage. The payload will finally attaches from the rocket and moves in the desired orbit. The aim of these stages is to send the payload to the space. The detached part of the rocket will drop into the sea or burn down during falling in the atmosphere. Wow, I would never guess that everything that we've been learning in physics so far are so deeply related to such a huge event like rocket launching. That's why I'm so glad to participate in this conversation with both of you.
Yes, Solomon. Time to stop sleeping and start concentrating more.
Oh, true. Time for the next class now. We will continue have this conversation another day. Bye.
Bye.
Bye.